In our project, we developed a heating and refreshing system for an office made up of more rooms. On a PC, we run temperature and motion simulation softwares. In fact, we don't use real sensors. On the other PC, we run the processing software, which is the core of the control strategy, and the linker softwares that, through REST HTTP protocol, allow data exchange between the broker that uses MQTT protocol and web services. The broker Mosquito is run by the Raspberry Pi together with the actuator software, which is responsible for turning on or off the LEDs. In particular, we simulate 2 rooms. For each room, the red LED represents the heating actuator and the green LED represents the refreshing one. Let's see in details how the system works. The sensor simulators have a unique configuration file in which are specified the season simulated by temperature software and the rooms in the office for which the simulation is run. Now the simulated season is winter, but it is possible to change it from winter to summer and so to simulate a different range of temperature. It is also possible to add or remove a room. Here, on the top, we see the motion simulator, which every few seconds simulates the entrance or exit of someone. In room 2, there are 2 people. In room 1, there are 4 people. These are the messages published to the broker. On the bottom, we see the temperature simulator. The temperature simulated in room 1 is different from the one simulated in room 2. And before the next temperature data publication, the software subscribes for motion and actuator data in order to simulate a realistic situation. These are the messages published to the broker.
The processing software subscribes for motion and temperature data of each room, and the management of the temperature is independent for each of them. These are the 2 messages received from the broker: motion message and temperature message. Here we can see the processing information and the message which is published related to the actuator commands. The temperature in room 2, in this case, is 21.8 Celsius degree, and since we are in winter and threshold temperature is 23 Celsius degree, the heating actuator should be on. The threshold temperature and the processing mode are set in the configuration file. Moreover, in this file, public holidays are specified. In these days, the processing strategy will be off. We see that the actuator message published for both rooms are heating on, and the same message is received by the actuator software. As a result, the red LEDs are on. The configuration file of the actuator specifies which LEDs are in each room. Thanks to the linker softwares, our system sends data to ThinkSpeak and Freeboard. In ThinkSpeak, we have 2 channels, temperature and motion, that receive data from the sensor software every few seconds. On Freeboard, we can see some information about the system, temperature threshold and number of rooms, and for each room the temperature chart imported from ThinkSpeak and the panel indicating the number of people. The light indicators represent the status of the actuators. In this case, both of the actuators are heating on. Let's test the system in summer mode. First, we have to modify the sensor configuration files, changing the season from winter to summer, and we run the temperature and motion simulators again. For this test, we also run a weather station simulator to generate a very high temperature values. For example, in this case, the simulated outside temperature is 33.1 Celsius degree. Then we have to modify the processing configuration file, changing the starting day of winter mode and set testing mode since we use a weather station simulator. In summer mode, the control strategy takes into account the outside temperature, making a subscription for weather information, and if the outside temperature is 7 Celsius degree higher than threshold temperature, this one is automatically increased of 3 Celsius degree. The aim is to have a more comfortable temperature. In fact, we can see the new update threshold that now is 26 Celsius degree. So, the actuator command message is we have to wait. Okay. The actuator command message is refreshing off for room 1 and on for room 2. In freeboard, we can see new simulated temperature in rooms and in the charts and the effect to the system. In fact, the indicator light refreshing is on for the room 2 and is off for the room 1.